So now what I want to show you, like summary recap. One more thing, like whatever we did over here, we have like z, x, gamma, other z. We can also have one more thing like dash, so that it can be helped in decoding. Like if we have want two z's, x, gamma and z, we have if we want two z's both. So in decode, if we encode this alignment like this, so we will in decoding we will get x is gamma z. But if we don't have dashes, we have encoded something like this. From decoding, these will be duplicates, and only once it will be taken, gamma jet will get. So we can, if dash is also there, its probability also will be calculated, so it will be helping in encoding decoding thing, duplicates, removing all those. So recap, summary, like setup network, we had to set up a network, then initialize again all the weights and parameters of the network, like all the CNN, base RNN by LSTM, which gives rise to bidirectional LSTM. Forward pass, get character versus timestamp probability score matrix, that is nothing but the this thing, like character row here, timestamp row here. Backward pass, construct modified character versus timestamp specific to ground truth values. Just take, for example, in this example, x, z, gamma, z vocab words in this rows. Just take those rows. Also take care about multiple character nodes. If you have two z's, means we used to duplicate again in that position, so that in that position only we need to grab, like first z, x, gamma, z means first row will be z. So z, x, gamma, z will be coming over here in this position only. It is like this, in this position we are assigned, because then only we can go like monotonically decreasing function, so that first letter will be always z and last letter will be always the last letter, or in this example z only. And here somewhere we get intermediate terms x, gamma, or again z we can get. Intermediate can be anything, but the first and last should be matched with the ground truth values. And again, if you go downwards, all encoding will be similar. If you will to do decoding, it will match with x, z, gamma, z in this example to the ground text value or ground truth value. So those things can be taken care if you go like this, in like left top position to right bottom position in monotonic decreasing manner, and perform forward backward algo to get this thing, like in posture probability arrangement. Again, we will do that because we have seen like most likelihood parameter, like in this each timestamp we can get highest, in this is highest, in this is highest, but that will not be the right in this is the highest, because we can find this is the lowest, from there we can find overall path is highest, that path is also we can find, right? If you have matrix something like this, if you find this to be highest, this to be highest, this to be highest, this, but the answer of ground truth value in training or testing, it may be not the same thing, because this is the lowest. Okay, if we go in this path, this is a like path may be the highest, so that's why we use Viterbi algorithm. So use to see which is the maximum highest path. So at first we have seen maximum likelihood, like at each timestamp we will see that is not beneficial, because that is like that can fit mostly to like sometimes it give good results, but sometimes it doesn't give good results, because it can fit to local maximum minima, because we need to find global maximum minima, right? Global optimal solution, maximum minima. So global optimal solution we need to find. So what happens is like if you find for highest path, like whichever is the most optimal path or highest path, lowest path. So optimal path if you are going to find, we use Viterbi algorithm. But now that also may not be, like we have some optimal cases as we have seen, like suboptimal nature of that technique which we are used using Viterbi so algorithm. So what we need to find is using like posterior probabilities, like using alpha beta of HMM. So all these Viterbi models, Viterbi algorithms, forward algorithm, backward algorithm, these comes in hidden Markov models techniques, and these are like components of hidden Markov models. So whatever there, what happens is like it is aware of all the situation, and it will like probability will be based on what we can say, this probability is based on all total valid paths. So the probability of all valid paths in the graphs, so all the blue, for example, this is not valid path for suppose, so all the blue are valid path for suppose in the graph for target sequence S, that can be like input sequence, or it can be actual target symbol sequence. That's nothing like ground truth values, ground text values, like training set values that goes through the symbol SR. Like if we have given Z, X, gamma, Z, so it goes to all the symbols in this path, this is like L rows, and this is timestamp T. Rth symbol in the sequence in S1 to Sk, like ZX comma Z for suppose, at time T. Time is T is equal to 0, T is equal to 1, so on, T is equal to T minus 1, and this is like L is equal to 1 to K minus 1, or K we can take 1 to K, or we can take 0 to K minus 1. Timestamp we can take 1 to T or 0 to T minus 1. So this is L and this is T. These variables are small letters, and constant thing like things are capital letters. So it will find for all the probabilities. So again we have seen that yt of x of L of yt of s of r is the probability of that word occurrence at particular time stat. That's it. But this thing is like, given that we have also given the target sequence, symbol sequence, input sequence, like ground to value ground test file, given that it depends on, it's a conditional joint probability, so there will be conditional independence can be there, all those can be there. But in simple yt s of r, that's just individual independent, those things are not there. Again it talks about occurrence of that word in the entire path, like whatever the valid paths which we have chosen for that graph, right? So based on these things are there, like what posterior probability we are taking. So in the posterior probability, like alpha beta which we are using, and then weighted averages we have talked before, and this is also kind of weighted average, because mean in statistics, like mostly mode is not that much used, or mode like maximal likelihood is not that much useful. Like mean is mostly used in some, again there can be exceptions always. And then computing derivatives for each yt, so we can get derivative or loss with respect to yt for suppose, and we can just back propagate to our bidirectional cell that is composed of like base RNN plus LSTM. Then we can also back propagate to CNN to feature enhancing also. For this instance it's something like this, and we get all zeros, and for particular yt or particular output we will get the component positive or negative non-zero component. And it's something like this: aggregate derivative over mini batch and update the parameters of neural network so that the training happens. And then prediction,